And hello, welcome to this video of LabView. So last time, I've changed and debugged this thing a little bit since the last time. Okay, one of the reasons, when I was debugging the whole thing, one of the reasons I found that there was some error is because let me delete this wire branch. Okay, and let's make it constant. Okay, so one of the reasons why we have that infinity error is because the starting temperature is 0 for a while. Okay, so let's play. Okay, I will just do, yeah. Okay, so what does the simulation return? Okay, stop. Okay, let me delete this. I will come to that part later. Okay, so what actually happened? Okay, what actually happened? It's basically, okay, we have a simulation returning infinity to the ODE solver. So what happened here is that this transfer function actually returns 0 Kelvin to the temperature feedback, and basically we have exponential minus EA over RC, which you have minus exponential of infinity. Well, technically that should be 0. Well, the solver just does not like that. Okay, so to help, usually what we do is, you can maybe add 273 to this temperature, or you can even just put 1 Kelvin offset. Okay, so instead of your transfer function giving a 0 or what, it will give 1 Kelvin at least. Okay, so this is what will happen. Okay, so the temperature will increase and increase. Yeah, so basically the idea here is that you try and give this temperature here a little bit of offset, so that when you do the feedback, it won't go to this very nasty temperature. Okay, so now the waveform is settling down, and I made it such that the heat of reaction is about 50,000 around this temperature, give or take, such that there is some actual feedback. Okay, we can make the heater a little bit hotter. So I have this baseline heater power fraction. Okay, so basically every 1 unit you add here, that will add about like 50,000 joules per mole. Okay, these are very arbitrary anyway, so it doesn't really matter. Just put 15. Okay, so it will go to very high, but okay, the thing is that even when you increase the temperature, the reaction heat isn't as high, because the temperature doesn't go up a lot, because the higher you go, the more heat output. The more heat will be consumed by this so-called endothermic reaction. So I have an endothermic reaction going on here. Okay, so as you can see, I'm putting in a sine wave, and we go through the whole Arrhenius thing which I was talking about last time. Okay, so now we are pretty much set. Okay, we have a input generator where we can have our power in like some dimensionless units. We have a power oscillation, and of course this oscillation frequency, which, by the way, never ever set this thing to 0, because if you do, then you have an error. So any number but 0. Okay, you cannot set your oscillation frequency to 0 Hertz, and maybe you can put 0.0001. Okay, anyway, the only reason why you want to do it is to just sort of switch off the oscillations. If you really want to switch off the oscillations, just turn the amplitude to 0, and then that's where you can actually control things a little bit better. Okay, Yeah, so that you can control things as if they were step response kind of a thing. Okay, so yeah, that's what we have. Okay, so again, yeah, the iffy thing about this simulation is it starts from near 0 Kelvin, but it's just what we have. Okay, it's just what we have. Okay, so now let's explain what's going on. Okay, I have a input chart. So the fuel to heater energy transfer function will be plotted using this heater power versus time, and that will sort of be an input. Though strictly speaking, the input for your the frequency response is this input generator fuel input, and that will actually control the fuel line, or rather it's just one input signal which will be translated into heater energy that will go into a resultant temperature of the reactor, and then you'll kind of just have this feedback loop. Okay, now question is, how then do we plot a chart? Okay, so there's an easy way and there's a hard way. Okay, the way it's done normally is that you try and use a report generation toolkit, which I do not have here. It's in Linux, so it doesn't have this toolkit. What's the alternative? Okay, the alternative is that you go to this waveform. Okay, go under waveform, because we'll be using this waveform data sets. Okay, you'll be using these waveform data sets, and we'll actually put it into Excel file. So let's have a waveform. Again, go to waveform, waveform file input output IO, and go to export to spreadsheet. Okay, and the waveform you want to use is for example, this heater power joules per mole versus time. Okay, so what we do have here? Okay, so we will need to use a local variable. Okay, change it to read, and I'll do a heater power joules per mole versus time. So let's do heater power joules per mole versus time, and then we'll wire that into the waveform. Okay, so we also need a path, which is we can create a control there. Okay, file path for inlet response. Okay, and okay, let me think. Yeah, actually I don't want to use this waveform. I actually want to use this one over here, so which I won't use heater power versus time, but rather this should be okay. Let's just call it fuel input versus time. I'm not very fussy, and just leave it as dimensionless, and the temperature will be in degrees C versus time. Okay, so this will be the fuel input versus time. Okay, there are two settings you need to do. I'll just list them down for you very quickly. One is whether you want to append it to a new file, and I will select true, so that if you have new data set, it will just add it to the bottom. And second thing is, okay, maybe yeah, let's show you this setup first. How does it look like? Okay, so I'll have a file path for inlet response. I will try and select, this is the waveform. Okay, if you want the output file to be waveform, just select waveform, or else you can just make a new directory, new whatever. Okay, a new file. So this is where I want my output to be. Okay, so again, we use this waveform, go to the waveform input output, go to export to spreadsheet file. So the inputs will be this waveform, the brown colored ones, a file path for inlet response, and then of course just append. Okay, append your waveform. Okay, And this is a convenient way to do it while the whole writing thing is in the while loop. Okay, usually if you want to write your data in the while loop and you write data real time, it's a bit more challenging, but this is one of the easier ways to do it. Okay, so let's try and see what happens. Okay, so what I'll do now is take a look at this waveform, and you can see it's steadily growing in size. Yeah, you can see it's growing in size. So yeah, the way you want to do it is not to open this file directly, but rather copy and paste. Okay, when you copy and paste, you will just get all of this data over here. Okay, now let's open it up with LibreOffice Calc or Excel, and this will come out. Okay, this will come out. So you will have a lot of pieces of data here. Okay, so let me close again. Let me open. Let's open with LibreOffice Calc, and make sure, okay, when you import your data, you can use space as one of the separators, because if you don't, all of this will be in the same column. Okay, I don't want to do that. I want space to help to delimit things. And over here you will have the time in hours, minutes, seconds, and 0.1, 0.2 kind of a thing. Okay, so these two you can sort of delete off. Okay, oops. These two you can sort of delete off, and you can see this waveform file is still growing in size. Okay, and you just move your mouse cursor around here, and it will show you the accumulating size, and you'll keep writing it to the file. Okay, so that's how you get your waveform. Okay, so you import it here. And yeah, you just append everything. Okay, and normally you'll kind of to get this in this neat format, you're supposed to actually have one more step. Okay, you do not write your headers. Okay, do not write your headers, because it will give you if you put write header, then LabView will think, I want to write headers. And the way when LabView does that, okay, let's see. If we start a new file, what will it look like? Okay, so again, I'm going to copy and paste. I'm going to open. Yes, if you look at this, and you try to import it, it'll be very challenging. Okay. Okay, let me open again with LibreOffice Calc. Yeah, if you import this file, it'll be very challenging, and this won't be in nice columns and rows for you to put in. Yeah, so this format of data is going to be very challenging. Okay, it's a very challenging way to write things. Okay, so if we don't want to do it this way, we will need to, let me close that. Yeah, we will then need to actually turn the right headers part off. Okay, because you will have all these extra. Okay, let me close that. MATLAB. Yeah, you will have all these extra things which you don't want. For example, time, you have some date, you have some T0 and all of this. Okay, you don't want all of these things. You want it in neat rows and columns of time versus let's say data. So I have to turn the write headers option off, turn the append to file on, because if you don't, it will be again difficult. Let me show you what happens when you try to just leave this part blank, or at least you turn it to false, because by default I think it's false. Okay, let's see what happens. Then you say replace existing waveform. Then you, at every time state, they'll ask you whether you want to replace which is something I don't want. Okay, so you have to turn this thing to true to have it run in the while loop, and turn the headers off. Okay. Okay, so the way to do it is like this. That's the optimum setup. You have a waveform dataset wired in. You have a file path for inlet wherever you want. So I do home user desktop waveform. Okay, that will be my inlet part. And if I press play, press run, then I'll do this. Oh shucks, I should not have opened that up. So the thing is that if you open this up, then you will keep going into this loop because the document has been externally modified. You want to reload it from disk. Okay, so try not to open things up. I mean, if you do, it's not the end of the world. But you know, this text editors will just keep asking you again and again. Okay, so I'll stop. Okay, not supposed to open that up, but let me delete this because it will keep appending data. So this is a little bit manual labor, but you know, it works. Okay, so now let's say once you have this waveform, let's copy and paste it, and then you have your data in this sort of format. Okay, so what then do you do? Okay, so open it with LibreOffice Calculator, and alright, so most of your time data is over here. You can see it's all over here, your time data. Okay, how do you convert it into like a nice seconds kind of a thing? So that's very easy. Okay, go to this. For example, this time is C4 in cell C4. You can minus cell C3. Then you have something like 1.15741 times 10 to the minus 6. Okay, multiply that by 86400. What's so special about this number? I'll let you know shortly. But you can see it becomes 0.1. You can see this, and you see the time over here. Timestamp is 0.1, 0.1, 0.2, 0.2, 0.3, 0.3, 0.4, 0.4. Okay, see the cells that I'm trying to highlight. Okay, maybe over here it's better. You can see the timestamp is 16:00:00.1, 16:00:00.2, 16:00:00.3, and so on and so forth. So you can see there are actually, like, you know, duplicate data sets here, but it doesn't really matter. Yeah, so what's the point I'm trying to make here? I mean, while there are some duplicate data sets which may prove a little bit annoying at times, but honestly speaking, it should not mess up your Fourier transform too much if you ever try. Okay, okay, so anyhow, why is 86400 such a special number? Okay, if you count the number of seconds in a minute, that's 60. If you count the number of minutes in an hour, that's 60. If you count the number of hours in a day, that's 24. 86400 is number of seconds per day. So this number you're seeing here is the change in time. Okay, change in time in number of days. So you can see this something whatever times 10 to the minus 6. It's basically times 10 to the minus 6 days of time elapsed over here. Alright, so if you want your timestamps, it's quite easy. Okay, so let's call this the start time. Okay, so let's use this cell and we'll minus C3. I'll press F4 to lock, and there you go. And you can just drag everything down, and you just multiply by 86400, and yeah, you go. And you have all your nice timestamps in seconds. Okay, this is a lazy way to do it. Of course, there are more sophisticated ways, but if you don't want to go through so much programming, this actually will suffice pretty nicely. Then if you want to just copy and paste your data over, you can just do it here, and basically you will have your fuel input. Okay, this is just dimensionless. I didn't really give much thought, and I can just insert a chart if I want to plot it versus time. Okay, let's see, insert chart. Okay, let's do a XY scatter plot. Okay, and basically it's a very boring scatter plot because it just shows that your fuel input is like 15 over time, which is basically a constant value. Nothing very interesting here. Now the interesting thing is probably you want to start oscillating the things, maybe by a fraction of 2. So yeah, excuse me. Sorry. Yeah, so basically if I do this fuel input versus time, we will see some sort of lag, and you see the temperature versus time graph is over here. Of course, yeah, we also need to consider the output. Yeah, hold on, this. Alright, anyway, so yeah, let's try to have another waveform made for the output response. Again, this is the easy way if you don't mind doing the little bit of manual labor later on. And basically it's just waveform input output, write to file. Okay, I will have a file output path. Let's make a control file path for output, and let's call this file path for input. Of course, you can actually do it in a more complex way, but this is the most basic way it can be done. Okay, let's quickly get a local variable in and change to read. Temperature in degrees C versus time. And of course we'll do the constant, append to file, and do not use headers. And let's clean up the wire. Okay, let's do that. And basically we have started, let's call this the input waveform. Okay, and this will be output waveform. Alright, now let's play. We'll have this oscillations at 0.1 Hertz. Okay, so yeah, we will be able to get our input and output, and as you can see, or maybe you can't see, it will probably be writing. It's writing data at this moment. Okay, so this is the easy way to actually have input and output. If you want something more complex, then you have to watch some other video, but this is the simplest way, the simplest least amount of LabVIEW programming you need to do. Okay, so yeah, yeah, after things settle down, we can pretty much start taking frequency response data, maybe 45 seconds onward. Okay, so the frequency response data, maybe it's 45 seconds onwards, you kind of take note. And of course, we can change yeah, we can change our input and output data, whatever. That's not too bad. Yeah. This is a way that works. Okay, one way that works. One for input, one for output. Okay, so I'm gonna stop now, and I'll see you guys next time. Maybe we'll think of some. We'll just continue where we left off, and we'll see how things go. Okay, yeah. Okay, see you.